our homework from yesterday. This is simplifying radicals. So everybody take a look at this and see if you have any questions. Hopefully it got a little easier as you went along. Yes, Jacob?
Can you go over 8, 10, and 12?
Number 8. Okay, so when you look at number 8, what is the largest perfect square that will divide into 54? Well, that is 9. 9 times 6 is 54. 9 is the largest perfect square that it divides into 54. Well, the square root of 9 is 3. And when you pull it out, it becomes multiplication. So 3 times 4 is 12. So the answer is 12 root 6. Okay, what was the other one? I'm sorry.
10.
Number 10. Okay, number 10 they asked for last period too. So let's take a look at number 10. Okay, we could multiply these together. Ooh, that is the easiest way to do it. Let's multiply these together, and we get 300. So it breaks up into 100 times 3. And the square root of 100 is 10, so it's 10 roots of 3. That's the easiest way to do that one. It's always great if you can pick the easiest method. Yes, ma'am?
When there's like a number outside the square root sign.
Correct. Yes, ma'am?
What do you do with that?
Like on number 8, when there's a number out in front, like 4 times the square root of 54, if I can simplify this, which I could, I brought a 3 out. The 3 has to get multiplied times the 4, because this is 4 times the square root of 54. So now it's 3 times 4 times the square root of, 6. So that's where the 12 roots of 6. So anytime you have something out in front, it means multiplication. So if you can factor anything else out, it has to be multiplied times that integer. Yes, ma'am?
Can you go over number 11?
Number 11. Okay, I think the easiest way to do this one would be to multiply it also. So 80 times 10 is 800. And what is the largest perfect square that divides into 800? Okay. So you see 100, but when I do 100, it's 100 times 8. Is there a perfect square that divides into 8? Yeah, 4 goes into 8 2 times. So we can think of it like this, 100 times 4 times 2. So the square root of a 100 is 10, and the square root of 4 is 2. So we have 2 times 10 out in front, which is 20, so it's 20 roots of 2.
Can you also explain number 12?
Number 12. We can multiply this one also, and we get 300. And 300 is 100 times 3. And the square root of 100 is 10. I did a lot of hundreds, didn't I? Okay, yes, Druva. Number 6. Okay, you may not pick 900 to go into it to start with, but we should be able to see that 100 goes in there. And so then we're thinking 100 times 45. Well, I look at 45, it's still fairly large. Is there another perfect square that will divide into 45? 9. 9 goes in there how many times? 9. 9 goes in there 5 times, yes. So the square root of 100 is 10. The square root of 9 is 3. So we get 3 times 10 outside, which is the 30, and we're only left with the square root of 5. Okay, anything else on the ones you can see, 1 through 12? We're good? Okay. All right, here is 13 through 25. Correct them, and then I'll ask for questions.
I have a question about like the whole curriculum. Are we learning the rest of the curriculum? Are we just going to learn about this, or are we adding more stuff?
Okay, the reason we're learning about radicals is we're about to use the distance formula. And to simplify the distance formula, you have to be able to simplify radicals. So that's why this is plugged in right here. Did you get them all right? Tim got them all right.
What's next? What's next?
Those of you listening to this just missed Tim's happy dance.
Can you do number 15?
Number 15. Okay, we talked about several different methods yesterday. And one of them was to look at what's under your radical and see if they had a common factor. So I'm going to throw that 3 and that 5 out in front, and then I'm going to think about just what's left under the radical. 7 divides into both 14 and 21. Do you see that?
Yeah.
So 14 can break up into 2 times 7, and 21 can break up into 7 times 3. Well, what is 7 times 7? 49. And the square root of 49 is 7. So you'd multiply all these. 15 times 7 is 105. And that leaves a 2 and a 3 under the radical, which is 6. And there's not a perfect square that divides into 6, so we're done. Okay? Number 18. All right, so we look at all of these, and this is all time. So I'm going to go ahead and take care of these integers out in front and make it a -6. Are we good with that? Okay. Now, if we look at this, I see that 6 and 27 have a 3 in common, so I'm going to factor 6 as 2 times 3 and 27 as 3 times 9. I look at 10, and these are my factors I'm dealing with so far. Well, 10 has a 2 in it, doesn't it, as a factor? One of the factors of 10 is 2. So we can rewrite 10 as 2 times 5. So what I would do at this point is start taking square roots. Well, this one's a perfect square, so what's the square root of 9? 3. Okay, this is also 9. So what's the square root of this 9? 3. So another 3 comes out. Well, this and this together make 4. What's the square root of 4? 2. So all of that I can take the square root of. The only thing left under the radical is the 5. Woo, that doesn't look... Moby has been doing some interesting things today. All right, there we go. So, 9 times -6 is -54, and if I double that, that's -108. So it's -108 root 5. Yes, sir?
How did you get number 22?
Number 22. Okay. One of our rules was we cannot have a radical in the denominator of a fraction. And the process we have in our notes from yesterday is whenever you have a radical in the denominator is to multiply the numerator and denominator by that radical. And yesterday we talked about that's really multiplying by 1. It doesn't change the value, it only changed the form. So that gives us 3 root 2 over the square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay?
Can you go over number 20?
Number 20. All right. This whole fraction is under the radical, and we can go back and forth with this. This means the same thing as this. I went straight to the answer. We're not there yet. Okay. So I don't know the square root of 5, but I do know the square root of 16, which is 4. Okay, yes, sir?
17.
17. I gotta erase some of this from 18 first. I don't have any room to write. Okay, so if we look at 17, we've got, let's go ahead and take care of our integer parts first. And that gives us 8. And then under the radical, we have a 3. 10 can break down into 2 and 5. Will the 2 help us? Yes, because there's a 2 and 6. So let's go ahead and break down the 10. And 6 can be broken down into 2 times 3. So now, 2 times 2 is 4. What's the square root of 4? 2. So the square root of 4 is 2. 3 times 3 is 9. What's the square root of 9? 3. So I can bring out a 3. So that gives me 48 root 5.
I see.
Yes, Drew.
Can you explain the difference of like solving 23 and 25?
The difference between 23 and 25. There's not a whole lot, because 23, we can take the square root of 4. 23 means that. So this is 2 over the square root of 5. So you would multiply by the square root of 5 over the square root of 5. So that gives us 2 root 5 over 5. Versus 25, I have a radical in the denominator, so I multiply the numerator and the denominator by the square root of 3. And that gives me 1 times the square root of 3, which is root 3, over square root of 9, which is just 3.
Okay, can you do like an example of 23 where you can't find the square root of the top number, the numerator?
That would be like a number 24, except number 24 can be simplified. All right, so here's an additional example. Let's do the square root of 7 fifths. Is that what you want? Something like that? Okay, so what does this mean? This means the square root of 7 over the square root of 5. So we would multiply by the square root of 5 over the square root of 5. So this is the square root of 35. Oh, y'all can't really see that. I'll go down. The square root of 35 over the square root of 25, which is 5. So that's the answer to my additional example.
So when it's written like they're all under one symbol, you can write it out like they're
Correct.
different.
Yes. Yes, Abby?
Okay, number 14.
Number 14. Okay, the numbers, so I'm not going to go any bigger with it. So I'll go ahead and break it down. Well, 15 divided into 90?
Yes.
6 times, doesn't it? So I would rewrite 90 as 6 times 15, because I already have a 15. And 15 times 15 is 225, and the square root of 225 is 15. So I get 15 times 2 is 30, 30 root 6. Anybody else, Daniel?
Can you go over
24. Okay, that's the only one on the bottom row I haven't done. That's all right. I can tell what y'all don't like. You are very clear. There's no confusion for me. Okay. The square root of 20 I could simplify first if I wanted to. So square root of 20 breaks down to 4 times 5. So this is 2 root 5 over the square root of 3. Well, I still can't have the square root of 3 in the denominator, so I have to multiply by the square root of 3 over the square root of 3. So this is 2 root 15 over 3. And that's 24. Are we okay? All right. Let's go ahead and pull out our notes from yesterday and finish up our radicals before we look at what we did for warm-ups today. Okay. Yesterday we did simplifying radicals. We did simplifying, multiplying, and dividing radicals. And when we multiplied and we divided, we don't have to be extremely particular about the numbers under the radical when we're multiplying and dividing. As long as we have the same type roots, so as long as we were dealing with all square roots or all cubed roots, we can multiply and divide what's under the radical. Well, when we add and subtract, it's a little different. You can only add and subtract roots that are the same, that have the same number under the root. So these are just some examples to help you understand. 2 apples plus 5 apples is 7 apples. 4x plus 2x is 6x. 6 roots of 3 plus 3 more roots of 3 is how many roots of 3? 9 roots of 3. But if we switch it up, 2 apples plus 3 bananas plus 4 apples plus 1 banana, can we add up all the numbers?
No.
No.
12 apples.
We add apples with apples, bananas with bananas. So that gives us 6 apples and 4 bananas. We can only group them by name, just like we did with variables. X plus 7y plus 2x plus 9y. We can't add it all together. We can only add our x's with our x's, our y's with our y's. So we got 6x plus 16y. Same holds true when we're dealing with radicals. What's under the radical must be the same, and it has to be the same root. So on this example, we're dealing with all square roots. So 5 roots of 2 plus 8 roots of 11 plus 4 roots of 2 plus 3 roots of 11. We have to add the like roots. So we'll start with adding those that were root 2. 5 roots of 2 plus 4 roots of 2 make how many roots of 2? 9 root 2. 8 roots of 11 plus 3 roots of 11 make how many roots of 11? 11 roots of 11. All right, because you may only add and subtract like radicals, the first thing you're going to have to do is make sure you've simplified everything. You want everything in simplest form so you can tell what radicals you're dealing with. And then you'll add or subtract the like radicals. Take that first example, and I would like you to just simplify all the radicals. did you get 2 roots of 3 plus 3 roots of 3 plus 5 roots of 3?
Yes.
Great. Great. That's what all these are simplified. All right, so we look at them. This is roots of 3, roots of 3, roots of 3. They're all the same. They're all like, so we can add them all. So the simplified answer to this is 10 root 3. Okay? Take the second example now, and I'd like everyone to simplify it. Okay, stop for a second. I need everybody to look out into the hall. They're doing a lab today. I want everybody to look. They're going to be jumping. I just need you to know that. So now we know what's going on, and we don't have to be distracted. Okay? All right, now go ahead and simplify the second example.
Were all your students last year?
It's the first year that they've done jumping.
Sorry, I did it right. I'm happy now.
It's getting cooler, I think. I need my sweater. Oh, it's dark and gray outside, too.
Is it still raining?
It's dark, gray, and cold.
I like cold
It's
weather.
cool.
And it's not gonna snow.
Okay, so let's take a look at what we simplified. Did you get 5 roots of 6?
Yes.
Did you get 3 roots of 2?
Yes.
Okay, what'd you get for 24? 2 roots of 6. And what about for 8? 2 root 2. Okay, so now we're going to add the like ones. So this gives me 3 roots of 6 and 5 roots of 2 plus 5 roots of 2. Now, you can see these listed in increasing order or decreasing order of the radical. Just don't mix up the order. Don't go like root 2 plus root 7 minus root 5. Don't do that. Put them in either increasing or decreasing order, okay? All right, so this one's fine. Okay, yeah, the last one.
Yes. Nope, you have to write the full word.
It's this, for those of you that I don't understand.
Yes. Thank you.
I'm blind. I can't see.
Got it.
They're cool.
You were so late. We already did a high five.
Okay, I hear the excitement. So, did we get 24 root 5?
Yes.
Okay, 24 root 5. So the first one was 6 roots of 5, and the second one simplified to 18 roots of 5. So 6 roots of 5 plus 18 roots of 5 is 24 roots of 5. Okay, some of you may be feeling really comfortable with this right now. Some of you may feel you need a little extra practice. So what I'm going to do is, I used the CUDA software and made a practice worksheet on simplifying radicals. I'm going to put it along with the answer key up on my website. Okay, so those of you that feel you need more practice with the radicals, go look there. All right, let's go over your warm-up now. In A, what kinds of lines did you graph right here? Parallel lines.
Never intersect.
They did not intersect. What did you notice was the same about all the equations? The slope.
Couldn't they be linear?
And what was different? The y-intercept. Okay, now,
They are linear.
they are linear.
Yeah.
Okay. On this one, what kinds of lines were these? These were perpendicular. All right, goofies. All right, what did you notice about the slopes of these lines?
Reciprocal.
Okay,
Opposite.
good. The slopes are the opposite reciprocals.
Nice, there it is.
Okay, and when I say opposite, what am I talking about opposite? The opposite sign. Good.
It's negative. It's flipped.
Okay, and what is the non-mathematical way to tell somebody how to get a reciprocal? You flip it. Okay. You did not just do that. All right. So these are the two things we need to be aware of when we're asked to find slopes. If we want a parallel slope, we take the equation and we do the same slope. If we want a perpendicular slope, we look at the equation and we take the slope and do the opposite reciprocal. Good. All right, so let's do the first one together. If we want a line that is parallel to this line, what would the slope be? 3/5. So a parallel slope would be 3/5. What about a perpendicular slope? -5/3. Flip it and change the sign. Opposite reciprocal. That's what that means. Okay. What about this one? Parallel slope. What would it be? -3. Perpendicular slope. +1/3. Okay. I want you to try 8, 9, and 10. You try 8 through 10.
Okay, so you make a parallel and a perpendicular.
Okay. All right. So for number 8, what is a parallel slope? 1, a perpendicular slope. Okay. Number 9, parallel slope. Perpendicular slope. Okay. Number 10 was a little trickier. Guys, do you know the shortcut when it's in this standard form, ax plus by equals c? Okay, so the shortcut is the slope is the opposite of your leading coefficient divided by the coefficient of your y. The opposite of the x coefficient divided by the y coefficient. Now let me show you why that works. If we were to solve this and put it in y equals mx plus b form, we get by equals -ax plus c. And so when we divide, we get this. Okay, so that's why that little shortcut works. That is why when it's in standard form, your slope is -a over b, and your y-intercept is c over b. That's why. Okay, so the slope of this one, a parallel line would have the same slope, so that would be -a over b would be +5/2. Right? Okay, or you could solve for y and get the same thing. And then a perpendicular slope would be the opposite sign and reciprocal. Okay, now it's asking us to write a line that is either parallel or perpendicular through a point.
It's -2.
Yeah, it's -2. So it would be
Yeah, so
2
it's
over
-5 divided by
5.
-2.
Oh, it is -2. So, what? I'm right. I'm right.
How is that? Because you're
Okay,
dividing by 2.
because it ends up being -5 divided by -2.
Oh, right.
Okay. All right. Okay, the second section.
Paying attention.
Use the information above to write an equation for a line. If we have a point and we know a slope, we're going to use that point slope formula. Y minus y1 equals m times x minus x1. Now, some of you like to just plug in here and then plug in the point in here and find B and then go back. And that's fine, but eventually in our math classes, I'm going to let you leave your answer in point slope form. Yes. Not yet. We're getting closer. But we will. So I want you to be really familiar with point slope, which is why I use it. Like on your, once you get to AP test, you'll be able to leave it in this form. It'll be okay. All right. So we want one that is parallel to number 6. So parallel, same slope through this point. So it's going to be y minus my y value, which is going to make a plus 2, equals my slope, parallel slope, same slope, 3/5, x minus my x value. Now when I simplify this, I'm going to get some fractions. It's okay. It's okay. They're not ugly fractions. So when I start to simplify, I'm going to come down here and show my work. I'll erase it in a second. But I get 3/5 x minus 18/5. And then I have to subtract this 2 from both sides. Well, this, I need to get a common denominator for 1 and 5. It's going to be 5. What number divided by 5 is 2? 10. So really what I'm doing is negative 18/5 minus 5/5. So I get y equals 3/5 x minus 28/5.
Completely.
Exactly what I got.
Okay, that's just algebra. That's not what we're doing right now. Okay, so y equals 3/5 x minus 28/5. So what the big point picture right now is, do I know parallel means same slope? And then I just plug it into point slope. And all I did was solve it. It just happened to have a fraction. But that's okay. Fractions are okay. You've been doing fractions since like 4th grade. They ought to be okay by now. Actually, it was before 4th grade. We actually start fractions in 1st grade. Okay. Okay, you try 12 and 13. You try 12 and 13.
Do we have to solve it?
Put it in slope-intercept form.
Oh. You don't have to solve?
Okay, I said put it in slope-intercept. That's y equals mx plus b. So get it to there for your answer.
Oh, so that means we are solving.
That's not really solving. Well, okay, you're solving for y. Yes, there we go. Solve for y. I'm not sure who's singing, but that can stop. Very seldom do I watch television, and last night was not one of those nights. I didn't watch anything. Okay, did you get them? Did you get them right?
No. I didn't finish because someone was messing with my paper.
All right, so let's look at number 14. What do you notice about the equation for number 13 and number 7? It's the same equation. So is it a parallel line?
Yes.
No, it's not a parallel line. It's the same line, isn't it?
Oh.
Okay? So even though we were asked to find a parallel line, it's actually a coinciding line. It means it falls right on top of the other one, right? Not parallel. And the reason is because the point 0,9 is on the original line. So if I ask you to find a line that's parallel to it, but I give you a point that's actually on the line, then you're not going to get a new equation. It's on the other line. Okay? Any questions? All right. The back is your homework. You should almost be finished before the bell rings. Okay? Some of you may be finished.